Hello everyone, welcome to another math online lesson. Our lesson for today is to solve linear inequalities and graph the solution sets in the number line. Now, what is the difference between an equation and an inequality? Okay, so in equation, there's only one possible answers, like what we did on our topic on solving linear equations in one variable. But in inequalities, we have multiple possible of answers. In fact, those possible answers can reach until infinity. Now I have here a linear inequality in one variable example. So same as what we did last time when we have our discussion in linear equation, the process in solving linear inequalities is the same. Now I want you to pause the video and try to solve for the value of x in such a way that it would make our inequality statement true. Do you have it? I'm guessing again that you're using the mental math in solving the unknown value of x. Now, like what I said earlier, linear inequality or inequality statements have multiple possible answers. Now, let's try to check if you get the correct answer. Now, I'll be showing you again two methods in solving this inequality statement. The additive inverse and the long method still applies to this one. Okay, again, I'll write the inequality statement x plus 4 less than 10. Now, using the additive inverse, we simply add a negative 4 here and a negative 4 here. Since x does not have any similar term, let's just bring down x. 4 and negative 4 cancels out, that becomes 0. Let's bring down the inequality symbol here. 10 minus 4, that is 6. Is your answer 6? If your answer is 6, then you are wrong, because 6 is not a solution to this inequality. Because if we try to substitute the value of x here, 6 plus 4 is 10, but 10 is not less than 10. 10 is equal to 10. So the possible answers here would be x, any value of x that is less than 6. It can be 5, 4, 3, 2, 0, to the negative numbers. So the possible answers here would be when x is 5 going to the negative infinity, right? So if you try to substitute any value of x from 5 going to the negative infinity, it satisfies our inequality statement. Now let's try to solve this one using the transposing method. So again, you have x plus 4 less than 10. Let's transpose the constant here together with the same term. Again, when we transpose a term, the sign of that term will change to the opposite sign. So from positive, it becomes negative. So what's left here is the variable x. Let's copy the less than sign, bring down 10, and then the transposed term, which is positive 4, and becomes negative 4. So we have now x less than 6. Now let's try to plot this one in the number line for us to fully understand the solutions of our inequality statement. Now I want you to take note of this. In plotting the number line, if the inequality symbol being used in the statement is less than or greater than, we use the open circle. But if the symbol being used is less than equal to or greater than equal to, we use the closed circle in plotting that one in our number line. Now this is our number line here. Okay, at the center we have 0. So going to the right we have the positive integers. We have 1, 2, 3, 4, 5, 6, 7, and going to the left from 0 we have our negative integers, negative 3, and so on. Now, since the value of x is less than 6 and the symbol being used in the inequality is less than, we use the open circle in plotting that one. So let's locate 6 in our number line. This is 6 here. So we use the open circle. Now what does it mean? It means that if the symbol being used here is an open circle, 6 is not part of the solution. And all the numbers less than 6 are solutions to our inequality statement. So it's from 5 going to the negative infinity. Here, going to the left. Okay, so let's try to have another example here. So I have here an inequality statement, x minus 2. This time we use the greater than equal to symbol of inequality and then 3. Again, go ahead and pause the video. Try to find the value of x that would satisfy our inequality statement. You have it. Let's try to check if we get the correct answer now. So we have here x minus 2 greater than or equal to 3. Again, using the additive inverse, I'll add a positive 2 here and a positive 2 here. I'll bring down x since x does not have any similar term. 2 minus 2, that is 0. I'll bring down the inequality symbol, and then 3 plus 2, that is 5. Now, did you get the correct answer or the same answer as mine? Now let's try to substitute 5, see if we could come up, or if 5 can make our inequality statement true. 5 minus 2 is 3. And since the inequality symbol being used is greater than equal to 3, then 5 is a solution to our statement. Let's try to use again the transposing method. The reason why I solve this in two methods so that you have options on how to solve this one. Oh, sorry, I'm using the transposing method for a while. Let me erase the... Okay, so I'll transpose this term to the other side to combine with its similar term. So what's left here is x greater than equal to 3. My negative 2 becomes positive 2. So I have x greater than equal to 5. Now remember what I told you earlier, that if the symbol being used is less than or greater than, we use the open circle. But if it's less than equal to or greater than equal to, we use the closed circle. Okay, again in our number line, you have 0 here. So our positive integers, you have 1, 2, 3, 4, 5. And then our negative integers here, going to the left, negative 1, negative 2, negative 3, and so on. Okay, now let's locate our answer here. 5 is here. Now, since the symbol being used is greater than equal to, then we use the closed circle. Closed circle means that 5 is part of the solution to our statement. So, any value of x equal to or greater than 5 are solutions to our inequality, meaning all the answers from 5 going to the positive infinity are solution to our inequality statement. Now let's have two more example. So I have here 2x plus 4. Again, the symbol being used is less than equal to 10. Now let's try to solve this one. I want you to pause the video and try to solve for x. Let's see if we could have the same answer. You have it? Okay, let's try to solve this one using the additive inverse. So I have here 2x plus 4 less than equal to 10. I'll add a negative 4 and so as on this side. 2x here does not have any similar term. I'll bring down 2x. Positive 4 and negative 4 cancels out. That becomes 0. I'll bring down the less than inequality symbol. 10 minus 4, that is 6. And like what we did in our lesson in linear equation in one variable, to solve for x, we need to eliminate the numerical coefficient by dividing it by its own numerical coefficient, which is 2. 2 divided by 2 becomes 1. 1 becomes an imaginary number, so what's left is x. I'll bring down the inequality symbol. 6 divided by 2 is 3. Did you have the same answer? Now, using the transposing method, I have 2x plus 4 less than or equal to 10. Transpose this one to the other side of the inequality. What's left here is 2x less than equal to 10 minus 4. I have 2x less than equal to 6. To solve for x, simply divide both sides by 2. 2 divided by 2 is 1. X becomes 3. And plotting this one in the number line, remember the symbol being used is less than equal to, so we use the closed circle. So we have 1, 2, 3, 4, and then you have your negative integers here. So x is less than or equal to 3. Sorry, this is less than equal to. Less than equal to 3, so any number equal or less than 3 are solutions. So we use the closed circle since the symbol being used is less than equal to. So less than 3, so that's going to the left. So from 3 going to the negative infinity are solutions to our inequality statement. Now our next example, I want you to do this on your own and kindly use the comment section for your answer. So I hope you learned something today. I hope you learn when to use the open circle and closed circle in plotting the result in the number line. Thank you for listening and see you on my next online lesson.